Hey students, this is section 9.4, equations of lines. We will change gears here a little bit because we have been talking about graphing equations. Well, in this case, instead of graphing equations, we are gonna be coming up with the equations. So in other words, they are not gonna give us the equation, we need to find it, okay? Because remember, up to this point they've been giving us the equation, well, either the equation or some information, and then we could make up some equation like this, well, a variation of this, and sometimes even this kind of equation. Well, in this case, they are not gonna give us the equation. We need to find it, okay? We're not supposed to graph, not in this section. We need to find equations with the information they give us, okay? And the easiest way to do that is to remember this equation, okay? And let me expand here really quick. We close that and expand that, and that should be good. Okay, so I was talking about this equation here. This is called the slope intercept equation, because m is the slope, the coefficient of x is the slope, and b is the intercept. So this is what gives you the y value for the intercept, and then all you have to do is think about the other value for that other pair, which would be 0. So let me get some paper really quick. Forget about that. There you go. Okay, so that B represents y-intercept, and you have been practicing that. That's good. And again, that B tells you the y value, that's x, this is y, of your y-intercept, okay? And this B tells you this y value, okay? It doesn't give you the whole order pair, but it gives you the y value of the order pair of the y-intercept. Then since you already have practiced this, you should know that the value for x should be 0, and that happens in every single case. For any y-intercept, the x value is 0. So that's how we get the x value for the y-intercept, okay? And this x is not this x, okay? Well, let me tell you what. Let's just forget about that. That was the explanation for this y value. I mean, for this or y-intercept, for the y-intercept, okay? Because now we need to focus on this here, which is a slope intercept formula equation. Y equals m x plus b is called the slope slope intercept equation, or formula. I forgot you call it a formula because we use it all the time. Yeah, we use it plenty. So slope intercept, and it is because we call it slope-intercept equation because m, the coefficient of x, is the slope, and the intercept is b. So b is the intercept. We already knew that though. Okay, so remember the name. Slope-intercept form. The slope-intercept equation is that. Memorize this too. Alright. Because if you can get any equation, any information they give you into this form here, you're gonna be able to graph the equation from here. Because again, this is the slope and this is the y-intercept. See, with the y-intercept, in other words, the order pair 0b, we can plot 1 point, and then with the slope we can either move up or down or to the left or to the right and be able to plot another point. Okay, and you'll see what I mean in the next section. Not in this section though. In this section we are going to focus on this form of the equation. Okay, well, I'm saying in this form of the equation, and I'm making it very specific because if for any reason all these values are on this side or mixed up, you're gonna need to solve for y. You need to remember to solve for y to make it into this form. Okay, or else your slope and your y-intercept are gonna be different. Okay, so you need to make sure you solve your equation is already solved for y, or that you solve for y yourself. Okay, and make it into this form. Another thing is that since we are gonna be we will find equations in this section. So in other words, something that looks like this, right? Equations that look like this with the information they give us. We need to know that y and x are always going to stay in the equation. Okay, y and x, I mean the variables y and x, like literally, they stay in the equation. Okay, everything else changes. Well, I'm talking about the values of m and b. They can change. They can change from equation to equation. So just make sure that whenever you write an equation in slope-intercept form, that you leave your y and x variables. Okay, your y and x variables stay, and I will show you what I mean, and I will explain to you again. Okay, so for example, let me move down here. We have a problem, or for example one, they're asking us to find the slope and the y-intercept of 2x, and this is just setting us up. So this is just setting us up to form equations like this. Okay, so in this example, they want us to find the slope and the y-intercept of 2x minus 3y equals 8. Okay, well, what did I just say the slope was? Well, m, the coefficient of x, and the intercept is b, the term by itself. However, remember that if you think about this 2 here as being the slope, that would be wrong, because remember that you need to set it up in slope-intercept equation form first. Okay, and so to say that 2 is a slope is wrong, and well, in this case, well, no, actually, let me see. Yeah, 8, to say that 8 is your intercept, your y-intercept, that would also be wrong. Okay, because you haven't solved for y. Okay, have solved for y yet. Therefore, you need to solve for y first. So don't let this trick you, okay? Even though the coefficient of x is a slope and the constant is your y-intercept, you haven't solved for y. Therefore, this information will be wrong, okay? And thus we need to solve for y first. Okay, so that's what I'm gonna do. Yeah. So that's what it's telling us to do. So that's what I'm gonna do. I'm just gonna rewrite the problem over here. Well, the equation 2x minus 3y equals 8. And from here I solve for y. And again, it's just like solving for x, like we've been doing. In this case, you always move the other term or the terms that do not have the variable that you're trying to isolate, okay? In this case, this whole thing. Since I'm adding here, well, since it is a positive 2x, I'm going to need to subtract 2x from both sides. Negative 2x from both sides. In this case, negative 2x, positive 2x minus 2x is 0. Just rewrite negative 3y equals. In this case, you'd be tempted to subtract a minus 2. However, this term is not like this term, okay? These two are unlike terms. This is a constant and this is a variable, okay? This is a variable except for you have two of these, two variables. That's what this two is telling you. So you cannot combine these two together. So all you can do is rewrite them. Just rewrite them. Okay? And from here, we use the multiplication principle. Since I'm multiplying here, I need to divide by the number I'm trying to move. And I need to do that to both sides. Okay? Negative 3 divided by negative 3 is 1. 1 times y is just y. In this case here, well, since I said that the coefficient of x was my slope and the constant was the y-intercept, see, I can't really tell what that is if I have a fraction like this. So what I need to do is to separate them, thinking about the negative 3 as being the denominator, the common denominator. Okay, common denominator. The operation is addition, so you are adding two fractions. So what we're doing is we're turning this fraction into two fractions. So that's what we're doing. That's what we want. Okay, negative 3. Don't forget that sign. Okay, and see how we have common denominators here. Well, think about this. If you add this, you keep the denominator. See, keep the denominator, and then just add negative 2x plus 8, which is this. So we haven't done anything to this except for rewrite it. That's all we did. Okay, and here you cannot combine these two together, remember? Okay, because this is a constant, this is a variable, even though you have two of these. Okay, all right, so now we're here. See, now I can see that my coefficient of x is positive 2x, and let me rewrite that because I have two signs here and I'm dividing. So when I divide two negative values, I get a positive. So this should be 2x over 3, and then this is a positive divided by a negative. That should give me a negative answer. Okay, so 8 over 3. All right, in this case now I have the coefficient of x, and the y-intercepts. And this is correct because I have solved for y. See, y is by itself now, so it is in this form already. So make sure you make, if you get something like this, an equation like this, make it into a slope intercept equation. Okay, which is what we did here. Now I can see that the slope is positive 2 over 3, and the y-intercept is the point 0. Well, let me see. Yeah, that's what they did here. So for the y-intercept, it is 0. The order pair 0, -8 over 3, and for the slope, it is 2 over 3, which is what we got. Okay. All right, and that's the way you find the slope. That's the way you find the slope and the y-intercepts when they give you an equation like this. Okay. We are not yet finding equations yet, but that's because they are setting us up. Okay. And then a line has a slope of okay, line has a slope of -2.4, and y-intercept 0.11. Find an equation of the line. See, now they're asking us to find an equation of the line. Okay, find an equation. Again, we need to remember that it is very likely that our equation is gonna look like this, like a slope intercept equation. Okay, and what information they give us? Well, they give us the slope, which is what we need to change, and the intercept also. See, which are the two things that change. Remember that y and x stay. You do not change y and x; those stay in the equation. Okay, so all you have to do is substitute -2.4 for the m, for the slope, yeah, and the y value in the order pair here, the y value for the b, and that's it. You have your equation. Okay, it is that simple. Okay, so let's move on and see if we get any other variations of this. Okay, a line has a slope 0 and y-intercept 0.96. Find an equation of the line. Again, if it would be nice if you wrote it down, you know, at the top of the page or your problem, the equation, the slope intercept equation. In that way, you just substitute underneath, like they did here. Substitute values. They gave us a slope of 0, and y-intercept of 96. Well, they gave us the order pair for the y-intercept, but you need to choose the y value and substitute it for the b. Okay, just the y value. All right, and then from here you are not done because you haven't simplified. So you need to multiply 0 times x, because if you multiply that, you get 0. 0 plus 96 is 96. Okay, so this is the simplified version of this. So this is the answer. Okay, and y equals -6. And what did we say that this means? Whenever you're missing a variable, it doesn't make a difference if you're missing x or if you're missing y. All it means is that for that graph, the y values are all gonna be -6. They are all gonna be the same. So for my points, all my points, yeah, the x are gonna be different. However, the y values are gonna be -6 for all these points. All right, and we're done. We're done with example 3. And then again, they gave us a slope and an intercept. Write down your equation substitute underneath for your slope in your y variable, in your y-intercept, the y-intercept you get from the y value of the order pair, plug it in there, substitute for the b, and that's it. If you can simplify here, it's simplified, but if you can't, that's it. That should be the answer. Okay, so this is the answer because you simplified that into this. Okay, let's move on to section B. Finding an equation of a line when the slope and the point are given. Okay, so we're still finding equations. Okay, like I said, this whole section is about finding equations, and then in this case they're gonna give us the slope and a point. Okay, slope and a point, not that y-intercept. Okay, however, we still use the slope-intercept equation. Okay, all right, so what information did they give us? Well, let's see. They gave us, for example, 5, they gave us find an equation of the line with slope 3 that contains the point 4, 1. Okay, so notice that they still gave us a slope, so that's good. However, they gave us a different point. They didn't give us the order pair, or as we this would be a 0 here, the y-intercept. They didn't give us the y-intercept. They give us a different point. However, this is still doable. We can still find the equation. Watch. So like I said, write down. It would be nice if you did, for at least for the first few problems, if you write down the equation, the slope-intercept equation, and then substitute values in there. So since they gave us a point, the point 41, what information are we missing? So like if I wanted to substitute these values in here, well, let's say I have slope of 3, my x, my y, and my x are going to be in the equation. Okay, so all of this stays in the equation, and then for my y-intercepts, well, they didn't give us one. So we need to write class B in here too, because they didn't give us one. They did give us a point though. They did give us a point. How do we use that to find the missing information here? Well, the missing information is B, isn't it? Because x stays and y stays, right? We already have the slope. So obviously the only thing we're missing is the y-intercept. Okay, how do we find that? By substituting these values into the equation and solving for B. Okay, so we went a little backwards there, but it is still mathematically correct. Okay, so in this case my x value is 4. I will substitute that in there for the 4, and since my y value is 1, I substitute that y for that 1 there. Rewrite everything else. Okay, I have multiplication between the 3 and 4 and an addition here. Okay, so all we have to do now is solve for B. Okay, solve for B. Well, the order of operation tells us to multiply first. Okay, always think about the order of operation, because if you don't, you're gonna get the wrong answer. Alright, so 3 times 4 is 12. So I'm rewriting everything else. Again, from here, if I want to have B by itself, I need to move the other terms, any other terms, as many other terms as you have over here, move them to the other side. In this case, we only have 1. We only have that 12 there. So we move that to the other side. Okay, and since this is a positive 12, the addition principle tells us to subtract 12 on that side and on this side to keep it balanced. 12 minus 12 is 0. 0 plus b is just b. So I re-roll my equal sign and my b. Okay, that b I just brought it down. Okay, and then 1 minus 12 is this is a subtraction basically. 12 minus 1 is 11, and the largest sign is on the 12. On the 12 is negative, so we keep that sign. Okay, so a negative 11. So b equals negative 11. Okay, so now we have found our b value. Okay, but we're not done yet. Okay, because they asked us to find an equation of this line. Here we were almost done at this point. See, we were almost done there, except for we didn't have that b, but now we do. So all we can do is all we have to do now is go back here at this step here, rewrite everything except for the b, because now I know that the b is negative 11. Okay, so that would be my equation. Okay, and y equals 3x negative 11 is my equation. So that should be my equation. Okay, and yeah, indeed it is. And that's how you would get the equation when they give you the slope and a different point, just one point. But it's not, this point is not the y-intercept. Okay, now if they give you the y-intercept, well, that's easy. That's easy because you can substitute in there for the b, and you're done. And then if they give you a point like this, well, set everything up first. Set everything up first, and then you can see that, oh, I don't have the b value. Okay, so I need to find that b. What do? Well, they gave us a point of this equation. Okay, and the reason it works is because the point they give us, this point, is one of the points that make up this equation. Okay, just FYI. And therefore you can substitute them in here. Substitute them in here for these variables, and then solve for b. When you solve for b, you have your y-intercepts. So just go ahead and substitute into the equation there, and that should be your equation, your slope-intercepts equation. Notice that here, when they ask you to find an equation, they don't tell you which equation, what form of the equation you need to use. So if you can find an equation that in slope-intercept form, that would be the easiest way to do it. Okay, so go ahead and use that. Okay, all right, so let's move on and work out example 6. Find the equation of a line with slope -5 that contains points -2 and 3. Okay, so same principle applies here. Go ahead and set up your equation and plug in all the information they gave you there. Well, they gave you the slope, but they didn't give you the y-intercept. They gave you a different point. They didn't give you y-intercept. Therefore, you're stuck here. See, you're stuck here, but you know that you need to substitute that b for some value, right? Yeah, the x and y stays, right, in the equation, but you need to substitute that b. Okay, so if I know that I need to substitute that b, I need to solve for b then. Okay, in that case, just substitute the values of x and y for the values they gave you. Okay, that's why they give you a point. Okay, and then just substitute the values in there, and solve for b. In this case, you multiply first. 5 negative 5 times a negative 2 is positive 10. Go to 10, rewrite everything else. From here, the addition principle tells you to subtract both sides by 10. 3 minus 10, well, that's a subtraction. Negative 10 and 3, so 10 minus 3 is 7, and you keep the sign of the largest value, which is negative 10. So you rewrite the negative sign there. Negative 7 equals b, and that should be value, your y-intercepts. You're not done, remember, you're not done yet, because they ask you for an equation. So you just go ahead and rewrite this part here, except for now you know the y-intercepts. So just substitute that in there, and you have your equation. Okay. Oops. Okay. There. All right. And that was objective B. Now let's move on to objective C. Okay. And objective B talks about finding an equation of a line when 2 points are given. So what are we going to be missing now? Well, the slope. They are going to give us 2 points, but they're not giving us the slope, right? So for example, for example 7 here, and let me fold my paper here really quick. For example 7, we need to find an equation of the line again. Let's find an equation containing the points 2, 3 and negative 2, 2. Notice that they did not give us the y-intercepts or the x-intercept for that matter, because we don't have any zeros here. That's how we know that. And they didn't give us the slope either. In other words, this part here. So far they have been doing so, but not this time. That means we need to find the slope and the y-intercept. In this case though, trying to find that y-intercept would be difficult, because remember how over here we found the y-intercept because we knew the slope. See, that's why we were able to find the y-intercept in the previous objective. Okay. In this section though, they didn't give us a slope. Therefore, this is telling us that we need to find the slope first, okay? Then we can find the intercepts once we found the slope. How do we do that? Well, the equation they gave us an equation for the slope, okay? And the equation is, and if I believe we already worked that out a few times, and in section 9.1 or 2, 9.1, I believe it was 9.1, and the equation, and I would rewrite my equation just to have it close to me and substitute values in it, like right below it. No, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so here notice that your y's are at the top and your x's are at the bottom. You can think of your y's as being your rise and your x's as being your run, okay? Rise over the run. And let's kind of practice this as much as we can. Y values, your rise, your x values, your run, and that's the slope. So you can say that your slope is your rise over your run, okay? And that's gonna help when graphing, so we need to practice that, okay? All right, so let's go back to this example here. My points are, and I'm gonna write them down here because I need to label them. Okay, I don't want to write on my book. Okay, I need to label them. That's 1 point, that's that point, and -2, 2. And you can separate these two by the word and or a comma. It's fine, it's not a problem. Okay, -2 and 2, and I need to label them. See, that's why I wanted to write them down here, because this is gonna make it easier when plugging in the values into the equation. Okay, so that's xy, xy, xy. Okay, in this case we need to choose which point is 1 and which point is 2. I always choose the first one as being my point 1. So this subscript here is telling us that this x and y are from point 1. This x and y are from point 2. Okay, so this is my point 1 and this is my point 2. That's this. These are my order pairs. See, now I can see that. I'm just gonna move that paper up here. Now I can see that I can move these values into the equation. Yeah, substitute them into the equation easily because I now have them labeled. So that's good practice. Okay, you need to do this as many times as you need to. Okay, or else you're gonna make many mistakes here. Okay, so I just rewrite everything except for now I'm substituting values here. My y sub 2 is +2, and then rewrite using negative sign there from the equation. Then y sub 1 is 3, +3, and all of that over x sub 2. X sub 2 is -2, minus from here, from the equation. Okay, rewrite those negative signs from the equation. And this is probably what you need to do first. Just rewrite the signs so you don't forget them. Okay, and then fill in the blanks. That's probably what you need to do. And for x sub 1, I have a +2. All right, and I'm done. Well, I'm done substituting values. Now use the order operation, and so subtract 2 minus 3. This is not a multiplication. I just wrote that inside a parenthesis, but this is not a multiplication because we knew that from here. See, these values were not multiplying, we're subtracting. Okay, so 2 minus 3. 2 minus 3 is -2. I mean -1, because this is basically a subtraction. 3 minus 2 is 1. Keep the sign of the largest value. It's negative. So 1. -1. -2 minus 2. Again, we were just subtracting because this is what it's telling us, this equation here. So -2 minus 2. Since both of these are negative, so whenever we have a two positives or two negatives and we're adding them up, we just add them up. 2 plus 2, and then keep the sign. 2 plus 2 is 4, and the sign is negative because both of them are negative, and we're adding them, we're not multiplying. Okay, and that's a big difference. Okay, in this case I can simplify this because I'm dividing and I had two negative values, so that turns into +1/4. Okay, and now this is our slope. Okay, see, that's our m. That's our m. Now we have the slope of this equation. Even though I don't know what that is, I do know that I want to make it look like y equals m x plus b, right? That should be your goal. Okay, and now I have the slope of 1/4 x plus b. Okay, I'm getting closer though, so this is good, because now all I have to do is substitute the b value, and this y and this x, they stay. Okay, they don't do anything to those, they stay in the equation. Okay, so this is telling me that I can substitute values for x and y and solve for b, because that's the value I need to find. Okay, so how do I get the values for x and y? Well, I just go back to my original points, the 1 points they gave me, and you can choose any of these 2 points, because both of these points are gonna be points in the graph. These are gonna be points that are gonna make up the graph. Therefore, these are solutions of this equation. Okay, so you can use any of these 2. Plug them in here, and it should give you the right value for b. Okay. Okay, so I'm just gonna choose the first one here, and the value for y is 3. So substitute 3 into the equation there. Rewrite your slope, and remember that this is multiplication, okay, between your slope and your x, and your x value is 2. Substitute that in there. Rewrite b, because we tend to solve for b. Okay, now just follow the order operation and solve for b. In this case, the order operation calls for multiplication first. So 1/4 times 2 is what? You just multiply numerator times numerator. Or you can think of this 2 as being 2/1. Multiply your numerators first, and that's 2 times 1 is 2, and your denominators there next. 4 times 1 is 4. Okay, plus b. Just rewrite everything else so you can see where you are. Don't skip steps. No, not at this point. Maybe later on, maybe skip steps, but not now. And then from here, remember that you need to move however many terms you have in here with the b, because you're trying to isolate the b. Okay, so if you're adding or subtracting, move those numbers first. In this case, I'm adding 2/4. In this case, I need to subtract 2/4, and then this adds up to 0. 0 plus b is just b, and whatever I do to one side, I need to do to the other. Okay, in this case, I can't see what I'm doing here. I know I'm subtracting 3 minus 2/4, but I'm not very familiar with this setup here. So I'm gonna have to rewrite that as 3 minus 2/4, because now I can see that these are 2 fractions basically. Okay, and I know that if I'm adding or subtracting, I need to have a common denominator. Okay, I know I'm gonna end up with 2 fractions, and the operation is subtraction. I know that the denominator, find the least common multiple. The least common multiple will be 4. So that's your should be your new denominator. If I erase, I did not. If I say this for this first fraction, the denominator I raised by a factor of 4. Therefore, I need to raise that 3 by a factor of 4. So 3 times 4 is 4. 4 times 12. I raised it by a factor of 4. Yeah, I raised it by a factor of 4. I raised this 1 by a factor of 4. Therefore, I need to raise this 3 by a factor of 4. So 3 times 4 is 12. Okay. And then I did not raise this denominator, so I don't have to raise that to the numerator either. Okay, just rewrite it. Okay, now we're ready to add, well, subtract in this case. 12 minus 2 is 10 over 4, because you keep the denominator. Okay. Alright, so let's go ahead and simplify here. 10 divided by 2 is 5. 4 divided by 2 is 2. So 5 over 2, 5 halves. Okay. 5 halves is my, well, let me go ahead and write it here. 5 over 2. 5 over 2 is my new intercept. Okay. So I'm not done yet, okay? I'm not done because I need an equation. Oh, I need an equation that includes the y-intercept. Okay, so that's y equals 1 over 4x, because I already know that the slope is correct. Okay, plus my b, which is 5 over 2. 5 over 2. And now I'm done. Now I'm done. Okay, that should be the slope. Let me just turn pages here and show you that it is correct. So the book says that we are correct. So that should be your equation. Okay, and that's it for this chapter. Okay, for this section. Okay, and I will see you on the next. Well, let me remind you again that in this section all we did was work on equations, find equations with the information they gave us, because so far we have been graphing the equation. In other words, they've been giving us the equation. However, this time we had to find the equation, okay, with the information they gave us. So that was the difference there. So I will see you in the next chapter.